Hello everyone, welcome to my channel. Now in this video we are going to start the chapter surface tension. This is the first video on this topic. So in this video we are going to discuss the basic concepts of surface tension, what is the reason for surface tension, how it arises, and what is the mathematical equation for surface tension. Those things we are going to learn in this video. So let's start the video. Now, as the name suggests, this surface tension, surface means the surface of the liquid, and tension means, in the chapter laws of motion you have seen, see, tension or any force, when we are talking about some force, external force, it means some unbalanced force. So some unbalanced force arising on the surface of liquid can be called as surface tension. Now suppose you have a vessel, and this vessel contains some liquid. Now, so these are the liquid molecules. Okay. Now, the liquid molecule, so there will be liquid molecules in the interior volume. There will also be the liquid molecules on the surface. Okay. Now, the molecule which is in the interior part of the liquid, now this molecule, it is acted by equal force. So there will be molecule on all sides, so there will be molecule on this side also. So this molecule, it will be attracted by equal forces on all sides. Okay, so it will be in a state of equilibrium. But the molecule which are on the surface, they are acted upon by force in the downward direction, and along the sides, but there is no liquid molecule above these molecules. So above these molecules there are air molecules, so there is very less interaction between these molecules and the air molecules. So these liquid molecules are interacting basically with the surrounding liquid molecules and also with the molecules of the vessel. Now that means for these molecules, they are acted upon by an unbalanced force. There is a force from the sides, there is force from the below the molecules, but there is no molecules, liquid molecules above these molecules. So that means these molecules are not in a state of equilibrium. The molecules in the interior of the liquid, they are in a state of equilibrium, but the molecules on the surface, they are in a state of unbalanced force. They are acted upon by an unbalanced force. Okay. Now we know that when a system is under the influence of some unbalanced force, it will have some extra energy. Okay. So these molecules, they will have some extra energy, and later we'll see that this energy of the molecules of the surface, it is called surface energy. Okay. Now how does this surface tension arises? Because of this excess energy, that we'll see now. Now there is a universal law that anything in this universe, they always try to stay in a state of minimum energy. Now I'm holding this chalk. Now if I drop this chalk, it will go down, it will not go in the upward direction. So this chalk, when I'm holding, it is having some potential energy, which is suppose it is potential energy, it is measured with reference to the floor. So if it goes down, it will be able to decrease its potential energy. Okay. So anything in that matter, anything in this universe, they always try to stay in a state of minimum energy. Now these molecules, they have some extra energy because they have some extra unbalanced force. So they will try to minimize this extra energy, they will try to minimize this force. Now see, this unbalanced force arises because of the surface, because these molecules are on the surface. So they will try to acquire the minimum surface area. Okay, they will try to minimize the area so that this energy decreases. So in trying to acquire this minimum surface area, they will acquire a curve shape. So this meniscus, it will be like this or it will be like this. Okay, so the liquid, suppose this is liquid water in glass vessel, so the meniscus will be like this. Okay, so this is water in glass, water in glass, and similarly if there is mercury in glass, The meniscus will be like this. So this is the liquid mercury. Okay, so they will acquire a curved shape. Okay, why they acquire a curved shape? To minimize the surface area. So they will acquire a spherical curvature. Okay, like this or like this. Okay, now why the surface is like this, why the surface is like this, that we will study later on, that based on some cohesive force, adhesive force, how this cohesive force, adhesive force gives rise to shape of the meniscus. That I will show you in the next part, second video of this series. Okay, now this video is basically discussing the concept of surface tension. So now this surface of the liquid, now we have seen that since they have some extra force, extra energy, they have acquired a curved shape. Okay, so now since these molecules, they have some extra force, so this surface, okay, now I can call this surface as a membrane, because this membrane separates, this is the interface between the liquid and air. Okay, so this is the free surface. So one more thing, important thing, this surface tension can acquire only on free surface. Okay, the surface which is exposed to air, okay, which is in contact with some other medium, only on that surface surface tension can arise. Surface tension cannot arise in the interior volume, because in the interior volume these molecules are attracted by equal forces from all directions, so these molecules are in a state of equilibrium. Okay, so surface tension is, this is the important condition, you must not forget that surface tension can arise only on the free surface. Now these molecules on the free surface, now they have, since they have this excess force, they are in a state of extra energy and they are in a state of stretched membrane. This membrane behaves like a stretched membrane, because this surface, it is acted upon by forces from all directions along the surface and also from below. Okay, so suppose visualize that this is the top surface, so there are molecules on the sides, there are molecules below, so these molecules on the surface, they are attracted from the sides, they are attracted from below, so these molecules on the surface, they are in a state of stretched, behaving like a stretched membrane. So this is known as surface tension. Okay, this is the phenomena of surface tension, this is the concept of surface tension. Now in physics there is one very important thing, it's like if you are able to define anything, any phenomena, okay, then you must be able to measure that phenomena. Okay, now since now we have defined surface tension, we should be able to measure surface tension. So how do we measure surface tension? Now let's see now. Achha, now suppose now this was the vessel containing the liquid, and suppose we observe this vessel from top. So this is the top view of the vessel. So this is the surface, top surface, okay, top liquid surface. Now this surface has all the molecules. Now these molecules are in a state of unbalanced force. So now we are observing this set of molecules along a straight line. Okay, now molecules, all the molecules which are on this side will pull these molecules in this side. So these molecules will force and will experience an attractive force in this direction. Now these molecules will also experience an attractive force on this direction. Okay, so surface tension, it is defined as the force per unit length on the plane of interface. See, this is the plane of interface. This is the interface between liquid and air. So force per unit length on the plane of interface is known as, is measured. So the force per unit length on the plane of interface is called surface tension. So if surface tension is denoted by the symbol T, so it is equal to F by L, force per unit length for this interface, for this plane. Okay, so force per unit length of the molecule, force per unit length experienced by these molecules, it is surface tension. Now how about the unit of surface tension? This is Newton, this is meter, so this will be Newton per meter. Okay, so this is the SI unit of surface tension. Now let's see a few concepts based on this formula. T is equal to F by L. Now suppose there is a needle floating on the surface of this liquid. Okay, the needle is pointing towards you. Okay, so this is the needle. So I am magnifying the size of the needle, this big needle. Okay, the needle is not so big, but suppose I am magnifying the size. So the needle is pointing towards you. So this is the interface. See, this is the interface between the solid and the liquid. So this is the interface. So these molecules, they will exert a force in this direction. They will also exert a force in this direction. Okay. Now suppose, so if this angle is theta, this angle is also theta. So this is the surface tension T. So this will be T cos theta, and in this direction you will have vertical direction, you will have T sin theta. Similarly for this it is T cos theta, and in vertical direction you have T sin theta. Okay, so that means, so this needle, so if suppose if this is the needle, so T cos theta, see T cos theta, all T cos theta will act in this direction, all T cos theta will act on either side. Okay, and all T sin theta will act in the vertical direction. So this T cos theta component for each part, okay, for each part along the length there will be all the T cos theta will be acting in this direction, or this T cos theta, and on this side in the opposite direction. Okay, so these T cos theta component, they will cancel out. So the resultant force will be this because of this T sin theta. So force, now what is the weight? Weight is acting in the downward direction, weight of the needle. Okay, now tension is force per unit length. Tension is force per unit length. So now see this T sin theta force acting for this side for length L. T sin theta acting on this side in the upward direction again for length L. So the total force will be, this force will be 2T sin theta into L. Okay, or you can write it as T into T sin theta multiplied by 2L. T sin theta for this length and T sin theta for this length. So T sin theta into twice L. Okay, and this mg is acting in the downward direction. So since the needle is floating, it is neither going upward direction nor it is going downward direction. That means T sin theta into 2L is equal to mg. For equilibrium condition, total upward force is equal to the total downward force. Okay, so this is the condition for equilibrium. So it is for the reason of surface tension, the needle is able to float on the surface of water. Similarly, and all those insects, they are able to walk on water. That is because of this surface tension. So I hope this concept is clear to you, and the phenomena of surface tension, the basic concept behind surface tension is also clear to you. So if you have really liked this video, please do subscribe to this channel, and also you can click the notification bell so that as and when I am uploading the videos, you can get the notification. And hope this my work and my videos are beneficial for you, and you do well in your academic endeavors. Good luck.